All right, so they want us to say which ones of these are congruent by angle, side, angle. So it's a good idea to be able to recognize what angle, side, angle means, right? Angle, side, angle means that our side has to be stuck between two angles, right? Well, if I look at these, okay, is this side here, and that middle triangle, is that side stuck between two angles that are being identified? No. Okay? That one would be that orientation of triangle QSR is, with the information that's marked, is like an angle side, isn't it? Okay? Hopefully we make the argument, we all understand that all those right angles up there are congruent, right? So that's your second angle that's being congruent, so they don't put marks in them, but that might be something you want to do. But this first set of triangles has an angle, a side, and then that angle. And that green side that I just marked is sandwiched between those two angles, right? Over here, do you have an angle, a side, and an angle sandwiched? Are those angles sandwiching that side? So then we're going to look at the first triangle and the second triangle. Sorry, the first triangle and third triangle as being the ones that are congruent. And we just got to name them correctly. Make sure if I go M, P to N, then I should probably go T, V to U. Does that help?
Somewhat, because on mine doesn't have, like, it doesn't, on all of that has one.
Okay, so you're, all right, let me generate a different one and see. So yours looks like that?
Yeah, that's
Is yours still asking angle, side, angle?
Yeah.
So again, angle, side, angle. I'm going to try to look at this and say, okay, this one here has an angle, and then there's a side, and it's another angle kind of sandwiches them, right? Okay. So now I go look at this one, okay, and I've got an angle and a side and an angle, right? And some people are going to say, oh, those are the two that are congruent. But that's not right because of the situation here of how many marks there are in these angles, okay? I guess not just the angles, but in the segments as well. That angle there has 2 marks. That one has 2 marks, right? That one there has 1 mark. That one there has 1 mark, right? So those angles are congruent. Those 2 respectively in this triangle and the 2 respectively in this triangle are congruent to one another. But this segment has 2 marks and that segment has 1 mark, right? So are those 2 segments congruent? No. Okay? So those 2 triangles are not congruent, at least looking at that information by angle, side, angle. Does that make sense? So we then look at this one over here, okay? And this one goes angle to an angle. Those are congruent. That angle has 2 marks. That angle has 2 marks. But now this side has 1 mark, and so does that side, right? So now you have angle, side, angle with those 2 figures. Does that kind of help? I think some people are struggling. I had a question in the last class about this as well. When they give me angle, side, okay? Remember, angle, side, the side cannot be between the 2 angles, right? Okay, if you struggle with angle, side, okay, try to convince yourself what angle, side, angle looks like. Try to convince yourself of the picture that we have up there and burn that image in your mind. Okay, because the next time that you see angle, side, then it'll be a little bit easier to recognize angle, side. Okay, it's going to be, if let's say that I look at a triangle like this, and that's the angle that I'm interested in. That's an angle I'm interested in, and then that's the side. You see how the side is not between the 2 angles, right? Okay, where up here, the side is between the 2 angles. So it's a good idea to be able to kind of drill those images in your mind, okay? Now, obviously, triangles might change from right to acute, to obtuse, to scalene, to whatever, but it shouldn't really matter the size of the triangles and the look of them. we should still always, if side angle side exists, it's going to look like the stuff that's up there in the green. If angle side is going to exist, it's going to look like something down there in the bottom right. So kind of burn those images in your mind and try to then match the problem that you're on to those images. Okay, and it might help you realize which postular theorem we need to be using. All right, I like this one. All right, so 3, it's finished. Let me unfinish it. What this is trying to get us at is to take a 2-column proof and use that as kind of like an outline, and let that outline then dictate how you would write what we call a paragraph proof. Okay. If we were to go through this using just kind of a 2-column proof, let's kind of maybe do that. Let's I'll go up to the board here in a moment, and I'll just write this 2-column proof in here. But then we'll see how that then relates to the choices that we make in what we call the paragraph proof down here at the bottom. If we're going to go through just a 2-column proof of this, okay, obviously the first thing would be given, right? I'm not going to take the time to write all that stuff out. That would be your given. The next thing you would write is that off of this perpendicular information, you would have what types of things? What is created by perpendicular lines?
Right angle.
Right angle. So let's talk about angle GSK and angle JSK. We would say are right angles. The reason would be definition of perpendicular lines, right? Okay. Then once those are right angles, what can you always say about 2 angles that are right angles? Congruent. So we say angle GSK congruent to angle JSK because all right angles are congruent. Step 4 then. So right now we've got that information. We were provided those 2 angles there were congruent. What is the 4th thing we need, or 4th step, which would be the 3rd congruency that we need here? Look at your picture. You know those 2 triangles are going to share what segment?
KS.
KS. So let's say KS or SK is congruent to itself. So what is that property? Reflexive. Okay. So now those 2 triangles. Okay. If we look at the parts, we've got 3 parts, right? Okay. 3 parts in both in the same order in both. It goes angle, side, angle, right? So I'm going to say triangle SJK is congruent to triangle SGK. And my reason is angle, side, angle. Okay? So I write my 2-column proof down. And this is something that you might be asked to do on an end-of-course exam. So this is kind of what you would want to do first. Okay? Think about going to English classes. You're going to write a paper in English class. What do they ask you to do first before you ever write a paper? So first thing, you guys write papers in English class?
Yep.
Okay, what's the first thing you always do? Put your name on it, yes.
I don't.
But you don't usually start, you don't sit at your computer, maybe someday you will.
Make idea.
But you don't just sit down and just start typing your final paper, right?
Make a rough draft.
Okay, a rough draft. What comes before a rough draft?
Ideas. Ideas like
Okay, and how do you organize those ideas? In a what?
in your head.
Starts with an O.
Organize.
Outline.
Okay.
You do outlines, right? An outline is to organize your information so that you can prepare a rough draft, right? Okay. Once you prepare that rough draft, then you start thinking, okay, this rough draft, maybe this paragraph isn't any good, I'll get rid of it. Maybe this sentence isn't good, I'll get rid of it. Maybe I need this new paragraph and this new sentence. Does that kind of make sense? And you start kind of repositioning things. Our 2-column proofs in general are a rough draft and an outline kind of wrapped up in the same thing. Okay. We would then want to take that information and transfer it over into a paragraph form. Okay, that's when you get to a college math class. Inevitably, okay, you're going to take a math course when you get to college, and some of them are going to ask you to do proofs. Okay, proofs of theorems, which just depending on the math that you're in, that might be all you do. Okay, but it might be something you do, once or twice throughout the semester. but you're going to answer that in a paragraph. You won't answer it as a two-column proof, okay? But we can use, at least in the geometry sense of things, we can organize our work here with this two-column proof, and now just transfer it into words, okay? And the way we transfer it into words is we just create basically transitions, like thus, and then, and so, stuff like that, that allows you to kind of piece together a prose-style writing format, paragraph. Does that make sense, everybody? So, when I start choosing my options here, okay, it says angle GKS is congruent to angle JKS. Well, why is that? You write because it is one of the pieces of given information, right? I want that thing to go away. There we go. Check my answer. Okay. So that's maybe the first sentence I would write, okay? And then from there it says blank because perpendicular lines form right angles. So which ones are right angles? GSK and JSK, right? GSK and, yeah, that one. Okay. Now what they do is they actually take the statements 2 and 3 that we had in our two-column proof, and they put it together in one sentence, right? We know they're congruent because they were right. They were formed by perpendicular lines, and perpendicular lines give you right angles, and then all right angles are congruent. So they take statements 2 and 3 and jam them together inside one sentence. Check that answer. Good to go. And now they say, okay, KS is congruent to KS because,
Reflection.
yeah, okay. Which, okay, you're right, reflective, but my options here are included sides between the two pairs of congruent angles, and that's exactly what we're saying when we use the reflexive property, right? But you're right, that's just not an option. But Gage, if you're writing this by hand, on the end, of course, again, don't say it that way. Use the reflexive property. All right, say KS is congruent to KS because of the reflexive property. And it's just a little bit better of a way of writing that. But now we've got that, okay? And then they ask us to go a little bit further. Why is KS congruent to KS? I guess they are asking us to put the reflexive property. And it's of congruent. So then, thus, another transition word. Those two triangles are congruent by what we decide is ASA. Okay. So that being said, these two statements, don't do that. All right, these two statements right here. That first one that I highlighted. They're trying to get you kind of on the path of using reflexive property. You don't really need to say that first sentence. You can just say straight out KX is congruent to KS because of the reflexive property congruence, and then go on to ASA. Okay. Does that help? That was actually